Alright guys, welcome back. Today we're going to talk about similar figures. Now first of all, recall similar triangles. For triangles, because they're so nice, the rules are not as strict. For example, if you have two triangles being similar, we actually only need either one of the following. First of all, at least two of the corresponding angles are the same. Second of all, corresponding sides are proportional. That's basically saying that you could have AAA or AA representing at least two of the corresponding angles being the same. Or you could have SSS or SAS. Notice that in this case the S represents the proportional sides. It doesn't necessarily mean that they have to be exactly the same sides. But today, when we talk about similar figures, we have to notice that for any other shapes other than triangles, two figures are similar if the figures are equiangular. That means the four angles need to all be the same. So we actually do need to check through all angles. Although you probably know that if I know, for example in this case, if I know three of them, then the last one, because 360 minus the rest of them, it's going to be exactly the same. But still, that basically means we have to make sure that all of them are exactly the same, like this. And on the other hand, we need to make sure that the corresponding sides are all proportional, like this. Notice that they don't actually need to be exactly the same. For example, if you have Z and on the other bigger shape we have KZ, you just have to make sure that we have also KW, KX, and KY. Now the following examples can really illustrate why we actually need to make sure all angles being the same and all sides being proportional. First of all, let's call the top one A and the bottom one B. What we're going to do is we're going to compare all the angles and all their sides. In this case, it's very easy for angles because all the four angles are being the same, so we're done. But then, now we need to check their corresponding sides. As you can see, in this case, 14 times 3 over 2 equals to 21, right? So 14 cancels out to 7. 7 times 3 is 21. And on the other hand, when it comes to the other pair of sides, we also have 10 multiplying 3 over 2. That gives me 15, which is the side length of the longer rectangle. In that case, we're actually saying that all the side lengths of the small ones will multiply by this fixed number 3 over 2 to get to all the corresponding side lengths of the bigger rectangle. In this case, we will say yes, all these sides are proportional and all the angles are being the same, so that's why we say it's similar. You see, that's actually a lot more work compared to triangle. Triangle is very good because we only need to check, for example, AA and then we're done. But in this case, we actually do need to check through all of them. Why is that? We'll look at the second one and you'll know why. Now again, the second one, you will have all four angles being exactly the same. They're all 90 degrees, so they're correspondingly exactly the same. So it's pretty fast for us to check through. But then for the side length, we actually have something that turns out to be a little bit disappointing. For example, in this case, if you take a look at the 36 multiplied by 2 over 3, that gives you a 24. But on the other hand, in order for your 24 to get to 18 of a smaller shape, you actually will multiply by 3 over 4. In this case, you will see that the ratios, the proportions, are not exactly the same. That's why all the four sides are actually not proportional. So in this case, we are a no. As you can see, even though these cases we have all angles being the same, that doesn't actually guarantee the similarity. Whereas in triangles, if you have all three angles being the same, we automatically guarantee the similarity. So that's the biggest difference between the similarities in triangle and similarity in figures. Now we're going to talk about this very, very key idea, scale factors. So on the test, or on any questions that you see on textbook, it will try to be very clear to you where exactly we want to go from and to. In this case, for example, if you are going from the big to small, you're going from here to here. What is the scale factor in this case? That's basically asking what number should each of my sides of the big triangle, right, from the big, multiply in order to get each of the corresponding sides of the small shape. So in this case, for example, what do you need to multiply 21 in order to get to 14? From the previous example, we know that the answer is actually 2 over 3. We multiply by 2 over 3 from 21 to get to 14. So in this case, the scale factor from big to small, in this case we call it reduction, the scale factor is 2 over 3. On the other hand, if you want to multiply a certain number for you to get from the small to the big, in this case you basically need to do the other way around. That basically means you can just, turn the fraction upside down. You will actually get your scale factors from small to big being 3 over 2. If the question does not mention from where to where, by default, we assume from the left to the right and from the top to the bottom. But usually what they will do is they will tell you, hey, can you tell me the scale factors from diagram A to diagram B? And then they will label which diagram is diagram A and which one is B. Now here's something a little bit confusing because some people in this world, they are defining the scale factor a little bit different way. For example, in US, sometimes we see people expressing the scale factor like ratios, right? For example, in this case, if you call this one small and the other one is big, right? So the scale factor of small to big, they actually use a ratio. They say the scale factor of small to big is 2 to 3, right? 2 colon 3, which is quite different to what we defined before. For us, the scale factor means if I want to go from small to big, how much do I need to multiply? Okay, but that's just something that you need to know. We will try to stick with the fraction form, which is what we saw above over here. But just so you know that, sometimes you could probably see people using this. Alright, 2 easy examples for today. The first one, pause the video if you'd like to give it a try. So we want to solve for an unknown, so let's label that x. In this case, we don't have to prove the similarity. We cannot prove anyway because we're not given enough information. They want us to assume similarity, so that means we're assuming that these two are actually similar. If they're similar, that means their scale factors should be exactly the same. That means the proportionality should be exactly the same. That means x over 24 has to be equal to 10 over 15. Right, this corresponding sides need to be proportional. Before cross multiplication, I would like to simplify a little bit. We got 2 and 3, and then we cross multiply, we got 3x equals to 48, x is equal to 16. Question number 2, again, label x. In this case, I have x over 25 equals to 12 over 15. Again, I simplify a little bit, this is 4 over 5. Cross multiply, I got 5x equals to 100, satisfying x is equal to 20. That's it for this question. Part 2, now they tell you the scale factor, and we're going to use the scale factor to figure out our x. In this case, our scale factor is 6 over 5. That basically means if in order for you to go from A to B, you need to multiply this number called 6 over 5, which makes sense because 6 over 5 is a number bigger than 1. If you multiply by something bigger than 1, you are only going to get bigger. So there you go, this is what it means. What I want to do is I want to multiply to the other side, and I want to distribute the 6 to 3x and 11. So this is what I'm going to get. I'm going to get 18x plus 66 equals to 210. 18x is equal to 144. X actually turns out to be a satisfying answer, 8. Okay, pretty easy. Right, so the red times scale factor equals to the blue. Second question. Again, this is my scale factor. I need to multiply from A to B. So there you go. 30 times 4 over 3. This is actually equal to 40. 40 equals to 3x. X is equal to 40 over 3. And that's it. So that's it for today, guys. I'll see you in the next lesson. Peace.